Hello everyone, welcome back to day 8 of Advent of Code. Let me explain the problem first. I have actually already done the solution, so today all I'll do is give you a quick explanation of how it works. Yeah, I don't know. Someone told me it was a nasty one, so I thought maybe I'll do it in quiet. It wasn't too bad, but took me a good amount of time, especially like debugging like the small chunks of things. But basically the problem, if you already haven't seen it, is you get bunch of frequencies. So those are represented by letters or numbers or any characters, not the hashtags but anything else. And the hashtag here is we're trying to find a position like antinodes in which the antinode is 2 positions away, is twice the distance of the 2. So basically, let me explain because it took me very long time to understand. So let me explain it like visually and it might make more sense, right? So you have these 2 frequencies and what you're trying to find is a antinode for these 2 frequencies where the distance to the antinode is double for one frequency compared to the other. So the distance from this to this is going to be half of distance from this to this. If you want to word it the other way, the distance of this frequency to this antinode is going to be double that distance from this frequency to this antinode. It's quite confusing, right? Already, so you have to keep doing that for a bunch of them. You ignore any places where they may overlap, and then that is basically it, right? So how I went about doing all this, look at this commented out code, because I started doing some maths for the line I was trying to create, or even before this I was trying to create gradients and stuff, but realized I was complicating it too much, so it was not necessary. So let me go one by one and it'll make sense. So we get our data like we normally do. Map size is just the size of the map. You can see it better like this. Yep, so map size is the size of the map, so the row and the columns. I have a 3D array for all of the antinodes, and then I loop through all of the frequencies, and the frequencies are created as a map. So we ignore, okay, this is what I was testing, but I won't need the hashtag really. But frequency is going to be a map in which I create the key, the frequency, so let's say A, and I will list out all of the other A's in that, so all of the same frequencies, because only for like the same frequencies that you can have the antinodes, right? So basically it just creates a map for all of the frequencies, similar frequencies. So there you go. So for all of my frequencies, I go through the index and find the antinode for that pair, right? For that pair of antinodes. So if I had 3, so what I'll do is I'll compare 0 and 1, find antinodes for that. I'll compare 0 and 3, find antinode for that, and I'll compare 1 and 3, find an antinode for that. But the actual finding the antinode part is this. So what we have here is the x1 and x2 positions. So these are the 2 pairs of frequency that we're trying to find antinode for. So like our first and the second item, right? A's. Maybe it'll be better if I open the input file and explain certain concepts, or if necessary, I was gonna say, but that's too much. Where was I? Find anti-node location. So I said, yeah, so this is just the coordinates, and this is just our map size we had before. I just had to convert it to float 64 because I didn't want to lose any decimals, just in case the coordinates messed up, so everything had to be in float 64. Dx minus dy, so this is basically the difference between the coordinate positions of our line. I guess that's also another thing. It didn't explain it quite well in the question, and that is probably why it took me a while as well. But basically, all of the antinodes will be within that line of that frequency. So all the frequencies are in a line, and the antinodes will also be within that line, right? So I find the difference up here for those frequencies, for the two coordinates. Antinode is from our first one, we take away the difference, and from our y position we do that, and we do the same for antinode 2. One of them we're taking away, one of them we're adding it, because think about this. So we have this line, right? One of the antinode will be further back, like down here, and the other antinode will be on this side of the line. So that's why we're adding that difference on either side of the line. I wish I could just draw it, but let's see. And we just check that the antinodes are not outside the map, and then we return that. Then once we're out here, we just have to remove any duplicates there might be, and that is it. Maybe give me 1 second, I might try to draw it out, but I don't have a good camera, so I don't know how that will work. Give me a second. Okay, done a quick drawing. I don't know how well you can see this, but I'll try to explain it from here. So A and B are our frequencies, and then C and D's are the two antinodes that we will find. But since that, this is when it clicked for me, right? Because everything is going to be in one line. So let's try to only calculate, let's say D, right? That is our antinode position. So we only want to find the position of D for now. That means, as you can see, one of the frequencies B becomes the midpoint between them. So that means the difference from A to B should be the same distance from B to D. So when we go from A to D, it'll be 2 times as when we go from B to D, if that makes any sense. So basically B becomes the midpoint. So we find the difference between A and B, and then we go to B and add that difference to get D, right? That's what we're doing up here. As you can see, we find the difference. That's like going from, that's the distance from A to B in X and Y dimensions. And then for this, we are just adding it to get to D. So let's say you can think of that. And in node 2, we get by adding that difference to our B. And then to get our C, we subtract that. And that is basically all you needed to do. That's all for today.